on what we know about exponents, let us try to do the following examples. Here we have 2 to the power 3x multiplied by 2 to the power 4x. Remember, we have laws of exponents and we have the rules. Looking at these laws, we can see that when the bases are the same and they are being multiplied, you can simply add the exponents. So which means that 2 exponent 3x plus 4x, this is expressed like this, and you'll have 3x plus 4x is 7x. Now we have simplified this one. Let's look at the next example. We have 2x to the power of 3 over 2x to the power of 5. So we can see that 4 over 2 goes into 4 2 times. Then you'll be left with x to the power of 3 over x to the power of 5. Then you will look at your rules and your laws. Now, when the bases are the same and you have the exponents, you can simply subtract the exponents. So what this means is that x, 2x, remember there is a 2 in front of the x, so 2x 3 minus 5. This will give you 2x negative 2. Then you look at the laws again. When you have the base to the power of negative exponents, you can express it as a fraction of 1 over the base to the power of a positive exponent. So looking at this one, you would have 2. So you'd have 1 over x squared. Looking at the next example, you have bases that are not the same. And then you have their exponents in brackets all raised to 3. You will look at your law. You have to know your laws by heart for your test purposes. Now, if you have 2 different bases, a and b, to the exponent n, you can multiply your n with the exponent and do the same for both bases. So let's repeat. When the bases are different and they are being multiplied and raised to an exponent, you can multiply that exponent with the exponent of the 2 bases. So what you will have is a to the exponent 1 multiplied by b to the exponent 1. Now n will be multiplied with the exponents of both bases. So 1 times n will be n, and 1 times n will be n again. So a to the exponent n multiplied by b to the exponent n. So let's look at what we have here. We have 3 raised to 4, and we are going to multiply the exponents. Multiply by 5, 2 multiplied by 3. And what you have here is 4 times 3 is 12, multiplied by 5 raised to 2 times 3 is 6. Now that one was also simple. Now say you have this expression. Now you can see that you have 2 over 6, which can be simplified, but then it is raised to 3. So your law says that when you're multiplying, you can simply multiply the exponents of all the bases. So 2 raised to 3, x raised to 3, and p raised to 3, all over 6 raised to 3 and x raised to 2 multiplied by 3. This means that you will have 2 to the power of 3 multiplied by x to the power of 3 multiplied by p to the power of 3 over 6 to the power of 3 multiplied by x. 2 times 3 is 6. So the law also says that when the bases are the same and you have the exponents and they're being divided, you can simply subtract the exponents. So here we have x and x. So this tells us that we can subtract the exponent of x. So you'll have 2 to the power of 3 multiplied by x. 3 minus 6 multiplied by p over 6 to the power of 3 multiplied by x to the power of 6. Oh, this x is not there anymore since we have it here, so you're not going to express it. And this will simplify into 2 to the 3 multiplied by x negative 3p raised to 3 over 6 raised to 3. And you can simplify this further because your exponent is negative here, and the law says when you have an exponent that's negative, you can express it as a fraction. 2 raised to 3 multiplied by p raised to 3 over 6 to 3 x to the power of 3. Now you can also simplify this and it will give you a proper value. So if you want to simplify this, you can say 2 times 2 is 4, 4 times 2 is 12, is 8, and then you have 6 times 6 is 36, 36 times 6, and then you can divide 8 over 36 times 6, and then once you're done, you will get your simplified answer. I can give you the simplified answer. You should find that 2 to the exponent of 3 divided by 6 to the power of 3, you will find 1 over 27 x cubed p cubed, right? So here we are asked to simplify. Being asked to simplify, you can see that you have 2, you have 4, you have 16. But you know that 4 can be written as 2 squared, and 16 can be written as 2 to the power of 4. So, which means that you will have 2 multiplied by 2 squared into n multiplied by 2 to the exponent 1 over 2 to the power of 4 into n. And simplifying this, you can add the exponents since the bases are the same. So 2 to n plus 2n plus 1 all over 2 to the power 4n. Simplifying this further, it will be 4n plus 1. So you have 2 raised to 4n plus 1 all over 2 raised to 4n. So we know that 4n plus 1 can be expressed as this, because when you multiply this and this, you add the exponents. So you have 2 raised to 4n. So this will cancel this, and your answer is 2. On the other hand, you have 5, and you have 9, then you have 15. Looking at this, 9 can be written as 3 multiplied by 3, or 3 squared, and 15 can be written as 5 multiplied by 3. That will give you 15. So you express that as your smallest base that you can have. So you have 5x multiplied by 5 negative 1. Remember, when you have this, You can write it as this because you know it was the exponents were added together. And you can also write it as 5 raised to x over 5 raised to 1, because you know, according to this law, you will subtract the exponents. So you can write it like that if you want, or you will continue and do that later. So we know 3 squared into x minus 2 all over 5 times 3 2x minus 3. Then what you do next is that you will simplify it further. So here, what you can do is that you can leave it like that and subtract the bases that are the same. So if we were to take this, so you have 2 methods. If you were to take this multiplied by 3, so you'll have 2x minus 4 over 5 2x minus 3 multiplied by 3 2x minus 3. So if you were to take it like this, you would simply subtract the bases that are the same. So 5 2x minus 2x minus 1 minus negative 3 will be positive 3 multiplied by 3. So you multiply that by 3, and then you have 2x minus 4 minus 2x minus negative 3. So it will also be positive. So what you're left with now is 2 minus 2 cancel out. Positive 3 minus 1 is 2. 2x minus 2x cancel out. Negative 4 plus 3 is negative 1. So you're left with 5 squared over 3, which is 25 over 3. This is one way to do it. Another method would be that since you have this multiplied by 3 to x minus 2 over 3 times 5 2x minus 3. So this is a different method. You would have 5 2x multiplied by 5 minus 1 multiplied by 3, 2x multiplied by 3 negative 4 all over 3 2x multiplied by 3. This is a 2 negative 3 multiplied by 5 2x multiplied by 5 negative 3. So in this method, you simply group the similar expressions. So where you have numbers, you'd group the numbers, and where you have x's, you'd group the x's. So looking at this one, you'll have 5 2x. You will subtract 2x, or they will simply cancel out like that, right? And you also have 3 2x. They will also cancel out. So what you're left with is this 5 negative 1 multiplied by 3 negative 4 over 5 negative 3 multiplied by 3 negative 3. So the negative exponents will go to the top, and the negative exponents on top will go underneath. So what you have is that when your exponent is negative, you express it as 1 over the exponent. So you have the exponent negative, so you will have it as that. And then when your fraction, in your fraction, the denominator, the exponent of the denominator is negative, you will have it like that. So these will go on top. So what you can see here is that this will cancel this, and you'll be left with 3. Okay, so because 3 to the power of 3 minus 4 is 3 negative 1, and this is equal to 1 over 3. That's why you're left with 3 here. And you will do the same for the 5. So 5, 3 minus 1 over 3 to the power of 1. So you'll be left with 5 squared over 3, which is 25 over 3. This is a longer method, but you can avoid mistakes and you will arrive to the answer simply without doing any mistakes during subtraction. Now we shall look at equating exponents. So you equate the exponents. To equate is simply to put an equal sign. So say you have an example that says solve x, where 3 to the power x plus 1 is equal to 9. Now first what you will do is have your 9 in terms of 3. So you know that 9 is equal to 3 squared, and you're already given that it is equal to x plus 1. After doing this, you will simply drop the exponents and have x plus 1 equal 2. Then you will solve for x. 2 minus 1, x is equal to 1. But dropping the exponents does not mean you divide both sides by 3 and they cancel out because you have the exponent here. It's simply a rule or a law where you make your bases the same, then you equate the exponents. Now let's say, for example, you have to solve x where 2 to the power of x is equal to 1. Remember from your law, a to the power of 0 is 1. So which means that 2 to the power of 0 is also equal to 1. Then you equate that to 2 exponent x. Drop the exponents, so x is equal to 0. You drop the exponents since the bases of the bases are the same, so you drop the bases. Now let us look at a different example. Say we have to solve x where 5 to the power x plus 3 multiplied by 5, x plus 1 is equal to 400. So you have that, okay? Knowing that simplifying this will give us 5 multiplied by x multiplied by 5 to the power of 1 equals to 400. And then you can, plus. You can see that you have 5 to the exponent x and 5 to the exponent x. So you can take out the common factor, 5 to the exponent x, and you'll be left with 1 plus 3 multiplied by 5 equal 400. So you know that 3 times 5 is 15 plus 1 is 16 equal to 400. Then you will divide both sides by 16. 400 over 16 is equal to 25. Now that you have 25, you know that 25 is 5 squared, so 5 squared. Then again, you will drop the bases and solve x. So thank you for watching. Please like and subscribe for more videos.